Damn, I feel alive. No more stressing out, no more mess around, no more getting by.
might look as though it's a very ordinary car, one that you'd see in everyday traffic. But actually it's a very different sort of car. And I'm just finding out a little bit about it. Well, Roy Doring, you've designed and built the electric engine that powers this car. How is it actually more advantageous than a piston engine car?
Well, it's more economical to run. It's noiseless, smog-free, and you look at the motor about every 15 years. That's all the maintenance you have as far as the engine's concerned.
Now, this is not a new idea. They've had electric cars for a long time. Why aren't there more of them about?
Well, about 50 years ago, these cars were much better than any petrol car at the time. And then as they progressed to the development of the petrol car, these became dormant for about 50 years. Nothing's been done. Although I've been driving them for about 30 years myself, and I'm a firm believer of their use. And they're smog-free, and they'll have to use them in congested cities.
Now, they're much cheaper than an ordinary car to run. Just what are the costs?
Well, to give you an example, to run this car on petrol for 4 shillings, you'd only do about 30 miles or 35 miles. I do for about 140 miles for 4 shillings.
How do you charge it up?
Just plug it into the wall. There's a charger built into the back of the car. Just plug it into the wall like an ordinary iron plug, and then it cuts itself off when the batteries are charged.
What sort of speed can you do in this car?
Speed varies. You set the speed to the type of country you're running it in, or township. If it's very closely populated, you govern it around about 25 to 30. But if you want to do faster speeds, you can go up to 50 if you want to, but it's not economical to run.
What do you mean, not economical?
Well, like everything else, you can't get something for nothing. And if you speed it up over 30 miles an hour, your amperage goes up, and of course the mileage drops in proportion.
And what sort of mileage can you get then on this car?
Between 20 and 30 miles an hour, you can do 40 miles on a charge.
Well, let's stop and have a look and see what this engine is like. Now, this is the complete motor, is it, Mr. Doring?
Yes, just the one motor. It is 64 years old. I've overhauled it. It has an armature through it, only one moving part. And the motor I took out, the combustion motor, had about 400 moving parts. So you can see they're quite simple, and you only need to look at the brushes by taking this plate off every 14 to 15 years. Just cleaning the commutator.
What about these other parts of the car? What are they?
Oh, these are what we call the clappers, or the speed control. As each one of these clappers come in, they cut more of the resistances out, and you go fast until you reach the last one, and then you've got the full speed, no resistance, you're going full speed, whatever you control the motor to run at, 30, 40 miles an hour.
And the batteries, I see there's only just 2 of them.
No, there are 13 altogether. There are 11 more in the back.
And are they normal batteries?
No, they're specially made traction batteries, have a greater capacity of acid, which makes it more suitable for traction work. You get much more benefit from them.
Is this the ultimate in batteries for a electric car?
No. We're just waiting for a breakthrough now on the batteries. When they get the breakthrough and we can dispose of the batteries, you can see that all that dead weight we're carrying around, you'll be able to get into the speed, range, and everything like that. And I estimate in about 1.5 to 2 years, with all the money they're spending now, all these big concerns, we will get it.
Well, do you think I could have a drive?
Quite simple. Anybody could drive it.
Okay.
See how easy it will be?
Pretty easy.
Just press the accelerator now and you go.
interest in this range of machines that we have collected here. This is the stator field system of an autosynchronous motor, and you will be particularly interested, I think, to notice that here we have a wide slot and a small amount of iron, and here a narrow slot and a large amount of iron. This feature, in conjunction with a concentrated winding, ensures maximum efficiency. Now, the purposes of the autosynchronous motor are really twofold. Firstly, to provide the power necessary to drive fans, compressors, and the like. And secondly, to correct the power factor of the system. This is a finished machine, and I'd like you to observe this particular component, the exciter, which, permanently connected in the system, ensures that you have a machine which is just as easy to start as a standard slip ring motor. Now, sometimes it is desirable that we have a totally enclosed motor, as for instance in dusty, dirty atmospheres, sometimes desirable in, for instance, power stations for boiler houses. Now, in this machine we have a unique system of ventilation which I particularly like to describe to you. Here you see we draw in the air in the center of the machine, and it passes along ducts which I'll now show you. By an ingenious device, we cut these channels out of the backs of the laminations, and in this portion here we have a tunnel through which the internal air circulates. You will observe how easy it is to clean these channels. Now, many of you will recognize here a traction motor. These machines are used for driving electric locomotives, tramcars, trolley buses, and battery vehicles. Notice how compact the machine is. One essential of a traction motor design is that it shall run at high temperatures and keep running.
Now come to Birmingham, to another factory of the group where electric battery trucks are made. You have seen these mighty atoms in railway stations, docks, and in 101 industries. Perhaps you've noticed them at work in these factories. In this erection line, for instance, we follow the familiar production sequence. First the frame, then the motor and the axles, followed by the propeller shaft, the steering gear, the battery box, and the connecting cables. The procedure is the same, whether the truck is an elevating truck which picks up a loaded stillage or has a fixed platform. Now a battery crane truck, which incidentally has seen 20 years service, brings the battery, made at New Malden, and lowers it into position. Charged overnight, this battery will run the truck for a full day's work. The battery in position, the cover plates are fitted, and the operator plugs in the connecting cable, so completing production. A tester now takes over, and the truck is put through its paces. There are 2 tons of concrete blocks on the platform of this truck. Great stress is placed upon efficient control, braking, and safety. Or come to Leicester, to the factory where electric road vehicles are made. The battery electric is the ideal vehicle for house-to-house deliveries. It is easy to drive and to get in and out of. It's silent and clean, needs the minimum of maintenance, and it's by far the cheaper vehicle to run. The chassis, the motor, axles and steering gear are all standardized components, but the bodies are varied according to the trade for which they're required. The baker's van is fully enclosed. The dairyman likes open sides. All are catered for along these assembly lines. You can see on the roads today 10 and 20 hundredweight delivery vans, 2, 2.5 and 5 ton flat deck lorries, and 7 and 12 cubic yard refuse collectors. In fact, 7 out of 10 electrics on the road today are Morrison electric cars. Come back to Chelmsford for a moment to the Crumpton-Parkinson switchgear works. Although standardized components are extensively used, every installation demands individual design. whether required for an electricity supply authority or a factory substation. Here we have an example of heavy metal-clad switchgear for important service, and for which great attention to test and initial adjustment, particularly contacts, is necessary. Every stage of manufacture requires specialized skill and care, as here in the insulation and taping of the high voltage joints and conductors, and the fitting and assembly of the unit busbar chamber. This is substation and distribution switchgear being erected in the shop. Upon completion, each equipment is subjected to the usual over-voltage tests, but in addition, breakdown and flashover tests are made on typical units to ensure maintenance of a satisfactory insulation margin. At these works is located the Crumpton-Parkinson High-Power Testing Station, one of the ASTA group of test stations operated by the National Physical Laboratory. This is the control room, located some distance from the testing cells. The control engineer in charge of the station is making his preliminary adjustments prior to the setting of the equipment for a test. The engineers in the station are preparing to start the machines, which are capable of producing energy equivalent to 1 million horsepower for the period required for the short circuit testing of circuit breakers. The temperatures of all parts of the plant are carefully recorded. The cooling water and lubricating oil pumps are running. All is ready. The high-pressure oil pumps are operated to ease starting, and the signal to start is given. On closing the switch, the 20-ton rotor commences to revolve, taking 20 minutes to gain its full speed of 3,000 revolutions per minute. In the meantime, the control engineer is making the necessary calculations, arranging for the correct connections of the reactors, and adjusting the excitation current of the generator to ensure the test conditions. He then signals to the machine room engineer to stand by. The control engineer has a final check-up on his side that all is ready. In the machine room, the engineer has a last look round and then presses the ready-to-start button, which lights a lamp on the control desk. The test button is then pressed and the test commences. The switch in the test cell, the generator up to speed and ready for the test. The master controller accurately times operations to 1/100th of a second and controls the sequence of switching. The electromagnetic and cathode ray oscillographs are recording the results. Generator field switches operating, switch operating in test cell. The cathode ray oscillograph was specially designed for operation with the plant and records the transient voltage at arc extinction. The film travels at 100 meters per second. Time marks are made at 10,000 per second. The engineer removes the exposed record from the oscillograph for development. These oscillograms are typical records of the test results. Sometimes, switchgear is deliberately tested to destruction to determine the factor of safety. The control engineer is now readjusting his circuit and gives instructions for the changing of the connection. To observe the performance of the mechanism and contacts, the effect of failure is reproduced by replacing the standard circuit breaker tank with one of light construction. The value of current in the test circuit is determined by adjustment of the connected external reactor. Connection changes are automatically signaled back to the control room by signal lamps. The operation current is switched on, the circuit conditions set. The signals, stand by and ready, go through, followed by the start signal. The greatly increased power caused failure of the lightly constructed switch tank, the oil caught fire, the fire protection apparatus was brought into use, and the flames extinguished. It's a natural step from switchgear to transformers, which are made at the works of the British Electric Transformer Company Limited at Hayes, Middlesex, another of the CP group. Here is a collection of the babies of the transformer world. Compare them with a larger one. The wire and strip used for winding are insulated with manila paper or cotton yarn in these machines. Insulation design is fundamental to transformer performance and is under the closest control. It takes a long time to make a good winder, and years of training, starting from the school leaving age, are necessary to acquire the technique. Blueprints and specifications are issued by the technical department, and every operator must be capable of using them. By far the largest percentage of the work carried out in this factory is of an individual, specifically designed character, so that operators very rarely have successive jobs of the same type.
It was that wonderful day not so long ago when the automobile first came to an American town. The grown-ups clustered around to gape and gawk at this elaborate, extravagant, outlandish method of locomotion.
You can turn back now or learn the stuff they don't want you to know. Here are the facts. Robert Anderson invented the first electric vehicle in 1839. Since that year, scientists have tried to improve upon the original concept, hoping that one day soon electric vehicles may break the world's addiction to fossil fuels. This technology has a long way to go. The best batteries on the market are still too heavy and take too long to charge. The range is still too limited, and the vehicles are too expensive for the average person. Although some of the world's best and brightest scientists are on the case, it looks to be at least several years before the average person can afford an electric car. But increasingly, conspiracy theorists disagree. In fact, many people believe the technology we need has already been invented, and that companies are purposely suppressing the electric car, using their political influence to keep the cars off today's market. Why? Here's where it gets crazy. This isn't the first time car companies have been accused of killing electric vehicles. In 1974, Bradford Snell of the U.S. Senate Antitrust Subcommittee alleged that General Motors conspired to kill electric trolley systems in 45 cities across the United States. Snell believed that GM was buying electric trolley companies in order to dismantle them, forcing cities and individuals to buy GM buses. Ultimately, GM was not convicted of monopolizing the trolley system, but their reputation never recovered. Fast forward a few decades to the modern age, where we still don't have an affordable electric car. According to analysts like Doug Kortoff, auto manufacturers have been dragging their feet for decades. In the film Who Killed the Electric Car, filmmaker Chris Payne alleges that General Motors purposely scrapped the Saturn EV1, an electric car, despite high customer demand. Representatives of General Motors claimed that there wasn't any money in the vehicle and that it was impossible to justify continued production. This makes sense. Car companies have to make money to stay in business, but in other ways it seems counterintuitive. After all, being on the forefront of a new industry could create billions in profit. Why would car companies purposely suppress innovation? Many conspiracists believe the explanation is found in the boardrooms of large oil companies. After all, these companies depend on petroleum-powered vehicles for a large portion of their annual revenue. Conspiracy theorists believe that oil companies have worked hand in hand with auto manufacturers, purchasing the rights to effective batteries and keeping them off the market. This seems possible, but it is far from conclusive. Car makers and consumer advocates can't even agree whether consumers want an electric car, but certain facts are indisputable. The current electric car technology is more expensive than the traditional gas-powered car. To some, this simply means that science hasn't cracked the design problems yet. To others, however, it means that oil companies and auto manufacturers have taken the technology of the future and kept it locked away. Is this possible? Could multinational oil companies have partnered with auto manufacturers to ensure short-term profits while ignoring long-term consequences? Is there, hidden away in some laboratory or archive, something they don't want you to know?
The automobile, which at first had been only for the wealthy, was being priced within the reach of most American families. There still were mechanical headaches, but the auto was here to stay.
Damn, I feel alive. No more stressing out, no more mess around, no more getting by.